In this tutorial, we'll learn about Hugging Face and how to build AI-powered applications. First, from Transformers import pipeline imports the pipeline function from the Transformers library. Next, pipeline sentiment analysis creates a pre-trained AI model for sentiment analysis. Then, the model is stored in the variable classifier. After that, classifier this tutorial is on Hugging Face sends the sentence to the model for analysis. The result usually shows a label like positive or negative along with a confidence score. This makes it easy to use pre-trained AI models without building everything manually. Next, you can use pipeline text generation from the transformers to generate text using an AI model. This type of model can continue a given sentence and create new content based on it. When you provide a starting sentence, the AI will try to predict and generate the next words in a natural way. For example, if you give it the beginning of a story, it will keep writing and extend it into a longer story. The model then prints the generated text, which may include multiple sentences forming a short story or paragraph. The model, like GPT-2 here, predicts the next token repeatedly, one step at a time, based on the context it has already generated. This ecosystem is maintained by Hugging Face, which provides pre-trained models and easy-to-use APIs for NLP tasks. We can build a question-answering pipeline using the Transformers library. First, we import the pipeline function from the Transformers library. Then, we load a pre-trained question-answering model using pipeline question answering. Next, we provide a context, which is the information the model will read. For example, we can use Python as a programming language. SQL is used for data science. After that, we give a question based on the context, such as, what is SQL used for? The model then analyzes the context and finds the most relevant part that answers the question. Finally, it prints the result, which in this case would be data science. This shows how a question-answering pipeline can automatically extract answers from a given text. We can also use the fill-mask pipeline from the Transformers library to predict missing words in a sentence. First, we import the pipeline function and load the fill-mask model using pipeline fill-mask. Then, we create a pipeline object called unmasker. This model is designed to predict the missing word in a sentence that contains a special mask token. Next, we give it a sentence like, machine learning is mask. The model looks at the context of the sentence and tries to guess the most suitable word that fits in the blank position. Finally, we print the result, which shows the predicted word along with a confidence score. The output will typically suggest words like amazing, powerful, or important depending on the model's understanding. This demonstrates how the fill-mask pipeline can complete incomplete sentences using context. The model may suggest words like king, powerful, or essential, along with confidence scores for each prediction. These words are ranked based on how well they fit the meaning of the sentence. We can perform zero-shot classification using the Transformers library without training a model on specific labels. First, we import the pipeline function and load a zero-shot classification model using pipeline zero-shot classification. Next, we create a classifier object. Then, we give it a sentence like, I love programming in Python. We also provide candidate labels such as technology, sports, and finance. These labels are possible categories that the model will choose from. The model then compares the sentence with each label and predicts which category best matches the meaning of the sentence. Finally, it prints the result, showing that the sentence I love programming in Python is most closely related to technology, since Python is a programming language used in that field. We can generate a longer story using the text generation pipeline from the Transformers library. First, we import the pipeline function and load a pre-trained language model such as GPT-2 using pipeline text generation, model equals GPT-2. Then, we create a generator object that will be responsible for producing new text based on a given input. Next, we provide a starting prompt like, once upon a time. We also set parameters such as max length equals 80 to control how long the generated story will be, and we enable sampling so the output is more creative and less repetitive. The model then reads the starting sentence and continues it by predicting one word at a time based on probability. It builds a full paragraph that forms a short story, extending the idea in a natural and readable way. Finally, we print the generated result, which will be a complete story beginning with once upon a time and continuing with imaginative content created by the model. You can continue the text generation example by adding more detail about how the model produces output. You can explain that the model keeps predicting the next word repeatedly until it reaches the maximum length that you set. Each new word is chosen based on the previous words, so the story stays connected and meaningful. You can also mention that different settings like temperature and top P affect how the story sounds. A higher temperature makes the story more creative and unpredictable, while a lower temperature makes it more stable and repetitive. Finally, you can say that this process allows the model to generate full paragraphs, or even long stories starting from just a single sentence, like once upon a time. We can build a simple AI chat system using the text generation pipeline from the Transformers library with a model like GPT-2. First, we import the pipeline function and load the text generation model using pipeline text generation, model equals GPT-2. Then, we create a generator object that will be used to produce responses based on user input. Next, we start an infinite loop using while true so the program keeps running and allows continuous chatting. Inside the loop, we take input from the user using a prompt like u. If the user types exit, we stop the loop using break. Otherwise, we pass the user's input to the model using the generator, set a max length to control response size, and generate the output text. Finally, we print the model's response so the user can see the AI-generated reply. This way, we create a simple chat bit where the user can keep asking questions and the AI responds until exit is entered. Inside the loop, the program continuously waits for user input, processes it, and sends it to the model for text generation. The model then produces a response based on the input and returns it as output. We can also improve the chat bit by adding better prompt formatting, such as labeling inputs clearly like user and responses like AI. This makes the conversation easier to read and more structured. Additionally, we can limit the length of each response using parameters like max length or max new tokens so the answers stay short and relevant. This simple structure demonstrates how a basic AI chatbot can be built using a text generation model like GPT-2. We can improve the chatbot by keeping track of the conversation history, so the model understands the context better. Instead of only sending the latest message, we include previous messages as well. This makes the responses more natural and coherent. We can also clean the output to remove repeated words or unfinished sentences. This helps make the chatbot's replies easier to read. Another improvement is limiting the response length so the answers stay short and focused. In addition, we can add simple commands like reset to clear the chat history or exit to stop the program. These features make the chatbot more interactive and user-friendly. Finally, we can turn the program into a web app so users can chat with the AI through a browser instead of the terminal. For instance, when a user types "Hey, what's up?" the AI might respond with a casual greeting such as "Hey, what's up?" The AI can also continue the conversation by asking a light or playful question to keep the interaction engaging. Sometimes, the response may include unexpected or creative elements depending on how the model is prompted. In this example, the AI responds to a simple greeting with a casual message and then asks the user if they want to join a band. Then the user can respond with something like "nice," and the AI will continue the conversation by generating a related reply, such as suggesting or sharing a song. This keeps the interaction flowing like a real conversation, where each message builds on the previous one. For example, after the user agrees, the AI might say something like "cool, let's make a song together," or recommend a specific music track depending on how the chatbot is programmed. In this way, the chatbot maintains engagement by reacting to the user's replies and continuing the theme of the conversation, instead of stopping after a single response. The AI can be programmed to recognize simple responses like "nice" and then trigger a predefined or generated reply, such as sending a song suggestion or continuing the theme of music. This makes the chatbot feel more interactive because it responds differently depending on what the user says. For example, if the AI suggests joining a band and the user replies "nice," the AI might respond with something like "awesome, here's a song idea we could start with," or recommend a specific track. This creates a more dynamic and engaging conversation flow. You have completed the Hugging Face crash course. You can continue by exploring other models, datasets, and tools available on the Hugging Face platform. This will help you gain a deeper understanding of how modern AI systems are built and used in real applications. You can also try building your own projects, such as chatbots, text generators, or image classifiers, to practice what you've learned. The more you experiment, the more confident you will become in using machine learning models effectively.